What is up, guys? DevCode here. Today we're going to be talking about building the parser for our compiler. Alright, so if you saw my previous video, you saw that I talked a little bit about compiler anatomy. So here's the article that I was talking about in the previous video. And basically today we're going to start building the front end part. This is one of the biggest and most complicated parts of the compiler, and then it gets a little bit easier. Alright, so today what we're going to be doing is we're going to get started with building the tokenizer first before we start on the parser. So now what we need to do is we need to create a new folder called parser. So I'm going to go here, create a new folder, and this is where all of our code's going to go for our parser for our compiler. And then in there, since we're starting on the tokenizer first, just create another directory called tokenizer. And now in here we're going to need to create a couple different files. So the first file we're going to need to create is going to be called token entity. So create that. Next, what we're going to need to do is we're going to create a header file called token type. And finally, we're going to need to create our tokenizer class. Alright, so now what we're going to do is we're going to start with the easiest file first, which is token type. So we're going to go into here, we're going to create an enum called token type. Basically what this is going to do is this is going to hold all the different types of tokens that our compiler is basically going to be expecting as input. Alright, so the first thing we're going to need to expect is a number. Next, we're going to want to check for any letters. Next is underscore, left paren, left curly, right curly, hash, dot, a plus sign, a minus sign, a multiplication sign, a division sign, a modulus sign, colon, semicolon, double quotes, single quotes, any commas that we find, new lines, less than or equal to sign, greater than or equal to sign. Alright, so to speed things up, I kind of just written out the rest. So basically we have equals equals, plus equals, minus equals, mult equals. These are basically like the math symbols. We have divide equals, and equals, or equals, XOR, mod, not equals, XOR equals will look like this, mod equals will look like this, or equals will look like this, and equals, div equals. We also have not equals, shift left and right, less than, greater than, and bitwise and, so a single and for comparison, or bitwise or for comparison, XOR not, sign, left brace. We also have a very special character or token type here, which is called EOF, which has a special value of 999. In C++, the compiler will generate unique values for all of these since we didn't specify them. But for this one, we want to specifically specify this as some complete arbitrary value. Basically, this is just specifying that we've reached the end of the file, so we can stop tokenizing our string. And then finally, we have not a type. If we just don't know what it is, then it'll come back. Alright, so before we go any further, basically what we have to do is now we have to start setting up the structure for our language. And what I mean by that is, how is our language going to be written? What is the syntax for our language? And the overall structure of how things such as a class should be written. Basically, the reason why we want to do this now is because it'll make it a lot easier for us to understand and visualize our language, because if we don't, we'll end up with thousands and thousands of bugs in our compiler because we didn't write out structure of our language beforehand. So what we're going to do is we're going to go up here to doc, and I'm going to create a new file, and we're going to call it grammars.txt. And basically in here we're going to write out the entire grammar for our programming language. The first thing we need to do is we need to start explaining kind of the bare essentials of our sharp syntax before we get to the more complicated things like variable declarations and so on. So you can kind of think of this as like stacking Legos. We start out with the foundation and we just build up from there. So the first piece of our syntax we're going to write is we're going to define what an identifier is. So basically the way we're going to define our identifier is anything that starts with a letter and any preceding characters after it can either be a letter, a number, or an underscore, any number of those in any order. Next, we're going to define what I call a native type. So basically what a native type is it's Sharp's natively defined keyword types. We're going to have two native types, which are going to be var and object. Our next type is going to be a number, and obviously a number is any character consisting of 1 to 9, including 0. Next, we're going to define a number set. And basically what a number set is a number that starts with a number and contains only numbers and underscores. So basically in our language, we're allowing the user to have underscores within inside of any number that they type out. Next is number literal. Basically, it can be a number set, or a number set dot number set. So basically, you can have something like this. You could have a number on one side, dot, and a number on the other side. And this basically represents a decimal. To speed things along, I'm just going to fast track the grammar file and explain things as I go. So next we have a string literal, which is basically just anything that starts with a double quotes and ends with a double quotes. And in order to add a double quote inside of there, you need to use an escape symbol. Next we have a Boolean literal, which is just true or false. Character literal, which is single quote, character, single quote, or we can have single quote, backslash, which denotes a special character to be printed depending on what letter comes after the slash. And finally, we have a literal, which basically consists of any one of the literals we listed above, which is number literal, string literal, character literal, or Boolean literal. Now we're at a point to where we have basically our basic foundation for our language syntax. So now we're just going to need to start building on top of this. The first thing we need to do is we need to define a model name. And basically what a module name is it's basically an identifier that connects a class to a specific module or directory. So if you want to access module java.io, this will kind of be the format for module name. And if you guys notice, I put some special symbols here. So obviously you know what the bracket identifier is. But then you see I have like this little square brackets here and then a parentheses inside of here. Basically what this means is I'm using what's called regular expression syntax. If you guys don't know what that is, I will put links in the description below on what regular expressions are so you guys can check it out. Next we need to define a reference pointer. Basically what a reference pointer is if you want to access something in the programming language. So let's say we wanted to access a variable inside of the Java.io class. The format would be java.io hash. This will be the module name, and then we would access the class system.out. Next we have reference identifier, which can basically just be an identifier or a reference pointer. All I'm really doing here is I'm further abstracting the lower level grammar rules so that way it will be easier to process them in our compiler. Next we have type identifier, which is basically a native type or a reference identifier. Next is value. And basically what a value is anything that amounts to a value in our programming language. And a value is basically an expression. Next we have a U-type, and this is basically a type identifier with brackets. Basically what this is this can be a native type, which is a type identifier of object array, or it could be some type of class that has array brackets right after it. Next we have a naked U-type, which is basically a U-type, but it's a type identifier without the brackets on the end of it. So like if you wanted to just create an object without the brackets, then you would use U-type naked for that. Next we have a value list. Although we haven't explained what an expression is, we are getting to it. But you can kind of see that now there's a little bit of a circular dependency between a lot of these different grammar rules, and we'll get to later on how to kind of connect all these together so that way it all works. So basically what a value list is you can kind of think of it as like if you have a function and you pass stuff into it. So basically here are some examples. You have a parentheses with the value inside, and remember a value is basically an expression, and you have a comma to separate the two values, and then you have another value right next to it. And then you can have any number of values splitting themselves up by commas, and then you end a value list by having a parenthesis on the other side of it. And value lists do not require, as you can see over here, it doesn't require you to have a minimum of 2 items. You can have 1. Next we're going to have a U-type arg optional. Basically this is a U-type with an identifier as an optional element right after it. And then you have a U-type arg, which is basically a U-type and an identifier. So basically what this is you can think of it as like having a U-type on the left side and a variable name on the right. Next we're going to have a U-type arg list optional. Basically what U-type arg list is whenever you create a function and you have to set up your local variables, you would set the native type and then give it some arbitrary name. Or in this case, if you had multiple local variables that you wanted to pass information into a function, you would set the type of the variable and then set the name and then so on and so forth. Next we have our vector array. Basically what this is something that you do that's similar to Java, where you would have some type of int array, give it a variable name, and set it to a new int array, and then you would on the fly set the values of the array without having to run them through a for loop and set the values individually. Alright, so now we're starting to get into the fun stuff. So first we're going to start off with a simple expression, which is called an assign expression. And this is basically anytime you want to have a variable and you want to assign it something to something else, we'd use an assign expression. An assign expression basically consists of equals, plus equals, minus equals, blah, 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 blah. These two aren't added. I didn't add it into the language that I have, so we probably won't be using these in our example for our programming language, but you'll get the gist of how all this kind of works once we add in all these different types of assign expressions. All right, so this is going to give you a little bit of insight to how my language is going to work and actually how complex and powerful it is. We're actually going to implement something that C++ actually implements, which is called override operators. And basically what that is that allows us as the developer to be able to add a feature into our compiler that allows programmers to override a specific type of operator built into our programming language that has one specific function that they can then make it do something completely different. So for those of you who don't know what operator overloads are, it's basically going to look a little bit like this in our language, where you have your operator and you're telling the compiler that I want to override the operator plus plus. Now, traditionally in a language, what plus plus normally does is it'll increment the variable that you have this symbol right next to. But let's say your variable wasn't just a simple integer variable, it was actually a class. You wouldn't be able to actually plus plus a class because it's not a numeric variable. So to get around this, you would create an operator overload on that class. Whenever this operator is written next to that class, the compiler would then know to jump into this function and execute the code in here. Next, we have array expression. Basically, what this is you have your expression, then you have your brackets, and then you have an expression inside of there with another set of brackets, and then a dot notation call expression. This dot notation call expression is optional. It doesn't have to be there. Basically, let's imagine we have a class that has a local variable called x, and then in that class, in that local variables class, it has a function called build task. Basically, build task would be your utype naked. Then we would process a value list, which would contain the variable or information that we want to pass into this function called build task. And then we would, after that, also check for another dot notation call expression, which would recursively come back into this rule to check for the same information. So then we would check for that dot yet again, and then we would see, okay, we have yet another utype naked, and then we have yet another value list, which doesn't require to have anything in there. You could have nothing, one element, or 1,000 elements. And then right after that, you have an optional array expression. So let's say this execute function return an array of objects, and we could possibly do something like at 4. So we would basically be getting the 4th element that this function has returned in this entire expression. All right, so now we're starting to get into what an expression is. First, before we get to what an actual expression is, we need to start off with understanding what a primary expression is. A primary expression is going to be the most commonly used type of expression. So basically, it could be a literal, or it could be something like a .utype.class. Let's say we wanted to access something like main.class. That would kind of be the usage for that. And then we also have dot notation call expression, which is this up here. So we're basically saying that our primary expression, or the type of expression that we would most normally run into the most frequent, we want that to be at the top of our expression parsing. Because as our compiler is compiling our file, we want our compiler to process everything as fast as possible. So if we know that these different types of expressions are going to be the most commonly used, we want those to be processed first, check to see if those are possible matches. All right, so now we finally got into what is called an expression. So this is where it gets a little bit more complicated. So basically, whenever we're trying to process an expression, first thing we're going to check for is it a primary expression? If it's not a primary expression, then we're going to check to see if what we're looking at is the keyword self. Self is a keyword. You can think of it as like this in Java that you would use to basically access a member variable inside of a class. If it's not self, then we would check for self arrow dot notation call expression. And basically what this is this is like in Java where you would say this dot some value. This is kind of the same thing, except we use a arrow instead of just a simple dot. Next we have base arrow dot notation call expression. Basically what this base does is, let's say we have a local variable called x in the class that we're currently in, and we also have a local variable called x in our superclass or our base class, the class that we're inheriting as a base, and we wanted to access that local variable. We would use base arrow and then dot notation call expression to access that local variable instead of using self arrow, because then there will be some ambiguity which variable we need to access. If it's not that, then we're going to check for null, which is also very common. If it's not null, then we're going to check for a new utype, valueless, and array. Basically what this is this is creating a new array. So we would have new int, and then we would either have vector array, new int array. Basically what this is we would have new int array, and then we'd possibly have a vector array where we inline the values of that array directly into the code, or we would have a value list. So like, let's say we wanted to create a new class called main, and then we wanted to pass information into the constructor of that class. Next is size of. Size of is basically going to be a way for us to get the size of elements in our code. So let's say we have an array that we don't know the size of. In Java, you would do array.length, and in other languages, they have other methods. But in our language, we're going to use the size of, kind of like how C++ does the same thing, where it gets the size of an object. Next, we have array expression. And then below that, we have a bunch of different combinations of expressions where we have an expression, a plus plus, a minus minus, and some different mathematical formats for processing an expression. So I won't get into too much detail about this and how this works. I'll just explain it once we get to that point. Next, we have what's called an access type. Basically what this is this is yet another set of private keywords. So in this case, we have public, static, and override, and constant. And if any of you guys in here have developed in C++ and or Java, I'm sure you guys know what all of these mean and how all of these would be used in our programming language. Next is comments. So we haven't yet defined how we're going to allow for comments to be put in the language. We're just going to do something simple, which is we're going to allow for a single line comment, which is basically just a double slash, and anything preceding that all the way up until the end of that line is null and void, and basically the compiler just ignores. Now we're going to start getting into different type of declarations in our language, such as function declarations, variable declarations, and so on and so forth. First, we're going to start with a module declaration. Basically, what a module declaration is you can kind of think of it as like a Java package. So in Java, Java has packages to be able to allow you to segment different files and different libraries. We're going to hold the same concept, except ours is going to be a little bit different. Basically, all you need to know right now is that each file is going to be classified into one single module, and you'll be able to import those different modules in different files to be able to access and utilize those throughout your application. Next is import declarations. So basically, if you want to import a module, you would type the words import and then your module name. And then in our language, just like most other languages, every statement that we're going to have is always going to end in a semicolon. We're not going to deduce anything like Python does, where it checks for different tabbing and stuff like that. Next, we need to explain what is a class declaration. So basically what we're going to have is we're going to have our access type, which you saw up here, which is basically public, static, override. Constant we won't be using for a class declaration because it doesn't make sense to have a constant class. So we'll have to check that in the compiler to make sure the user isn't typing that. Basically, we'll allow for public, static, and that's it. In our language, if we want anything to be private, you would basically assume that everything that the user creates is defaulted to private. If the user wants a certain class or variable to be accessed outside of the file that is in, they're going to need to specify whether or not it's public. So basically in a class declaration, as I was saying, you have your access type, class, you have your name, and then you have your base and then reference identifier. Next, here's an example of a block. So this represents a block of code. Basically, a single block of code it starts with a bracket, it has any number of statements in it, and it ends with a bracket. All right, so I've added a few more different types of declarations here for you. Basically, you can look these over. Basically, I've added a class constructor declaration, a way for you to create methods, a way for you to create operators and variables. Finally, I've added the rest of the things that are going to be in this file. Basically, I added the last fundamental parts of the language, so things such as if statements, while statements, do while statements, for loops, for each, catch statements, finally blocks, try catch statements, throw statements, macros, declarations, and so on. But the most important thing down here is how we structure our statements. So basically, we classify a statement as any one of these things in here. So a statement can be a return statement, if statement, while statement, do while, try catch, throw, continue, break, go to, identifier, variable, expression, or ASM declaration. So yes, a statement can be an expression, but in our compiler, we're going to have to check to see if the expression evaluates to any one value. If the expression doesn't evaluate to a value, then it won't be considered a statement. And every single statement in our programming language always ends with a semicolon. So right after we read that we're processing a statement, we're going to expect a semicolon to be right after it. But if it's something like an if statement or a while statement, we obviously won't be expecting semicolons after those. All right, so now that we have our basis for the grammar for our compiler and what we're going to be processing for our tokenizer, I'm going to stop here and we're going to continue this on the next episode. So hopefully you guys enjoyed the video. Definitely like and subscribe if you guys liked it and you want to see more. So until next time, see you guys later.